Rationalizing the denominator. Let's start this session with an objective to understand the process of rationalizing the denominator. If the denominator of an expression contains roots, it could be square root, cube root, or any other number with a radical sign. Then, converting the given expression in a way that it gets free from radical sign, which means denominator becomes a rational number. This process is called rationalization of the denominator, and the irrational number with which we multiply the numerator as well as the denominator is called the rationalization factor. Let's try to understand this concept with the help of a very simple example. 1 by root 3. Looking at its denominator, we can clearly see a square root sign with 3. Now, in order to rationalize this denominator, root 3, we need to convert it to 3 by removing the root sign. How do we do it? By which number should we multiply root 3 so as to get 3? Simple, it's root 3 because root 3 into root 3 gets us 3. So we multiply root 3 into the denominator as well as the numerator so that the value of the fraction remains same. We get root 3 by 3. Look at the denominator. There is no radical sign of any order. Thus, the denominator is rationalized. Root 3 is the rationalization factor in this case. It means the rationalization factor for 1 by root a is root a, which we can use to solve all the similar questions which are in this format. Similarly, if we have to rationalize the denominator of 1 by 3 plus root 2, then 1 by 3 plus root 2 should get us a fraction with a rational number in its denominator. So, what shall we multiply with 3 plus root 2 to get it free from radical sign? Remember the identity? A plus root b into a minus root b is equal to a square minus b. Thus, 3 plus root 2 into 3 minus root 2 is equal to 9 minus 2 is equal to 7. So, we multiply 3 minus root 2 into the denominator as well as the numerator in the given expression. We get 3 minus root 2 by 7. Here, 3 minus root 2 is the rationalization factor. It means the rationalization factor for 1 by a plus root b is a minus root b. We can use this to solve all the similar questions. Now, let's change the positive sign in the given expression to negative and see what will be the result in this case. So now we have 1 by 3 minus root 2. Let's change plus to minus here also. The identity used to solve the question remains same. Although, just for easier understanding, let's change the signs in identity too, changing minus to plus and vice versa. But the result remains the same, which is a square minus b. Same way, we change plus to minus between 3 and root 2, and here minus to plus between 3 and root 2. But the result remains same, as by changing the signs, we are just exchanging the positions of these factors. So the rationalization factor now becomes 3 plus root 2, as the denominator is 3 minus root 2. It means we multiply 3 plus root 2 into the denominator as well as the numerator, thus getting the result as 3 plus root 2 by 7. It means the rationalization factor for 1 by a minus root b is a plus root b. In short, we can combine the two and write the rationalization factor for 1 by a plus or minus root b is equal to a minus or plus root b. We can use this formula to easily rationalize the denominator of all the similar numbers. Same way, we can also rationalize the denominator of 1 by root 3 plus root 2. First of all, we have to find the rationalization factor for root 3 plus root 2. So we get a rational number in the denominator. Remember the identity root a plus root b into root a minus root b is equal to a minus b. Applying the same for root 3 plus root 2, we can multiply it with root 3 minus root 2 to get 3 minus 2, which is equal to 1. So we multiply root 3 minus root 2 into the denominator as well as the numerator in the given expression. So we get root 3 minus root 2 by 1, which can be simply written as root 3 minus root 2. Here the rationalization factor is root 3 minus root 2. It means the rationalization factor of 1 by root a plus root b is root a minus root b, which we can use to solve all the similar questions which are in this format. Now let's change the positive sign in the given expression to negative and see what will be the result in this case. So now we have 1 by root 3 minus root 2. Let's change plus to minus here also. The identity used to solve the question remains same, as we are merely exchanging the positions of these factors. So the rationalization factor now becomes root 3 plus root 2, as the denominator is root 3 minus root 2. It means we multiply root 3 plus root 2 into the denominator as well as the numerator, thus getting the result as root 3 plus root 2 by 1, which can be simply written as root 3 plus root 2. It means the rationalization factor for 1 by root a minus root b is root a plus root b. In short, we can combine the two and write the rationalization factor for 1 by root a plus or minus root b is equal to root a minus or plus root b. We can use this to easily rationalize the denominators of all the similar numbers. Now, let's understand this concept of rationalizing the denominator with the help of some simple examples. Let's rationalize the denominator of the given expressions. Our first example is 1 by root 2. Looking at the expression and following the rules learned so far about rationalizing the denominator, we can easily see that the rationalization factor here is root 2. So we multiply the denominator as well as numerator by root 2 respectively, which further simplifies to root 2 by 2. We can clearly see that the denominator is free from any roots or radicals, thus the denominator is rationalized. Our second example is 1 by 2 plus root 3. Rationalization factor in this example is 2 minus root 3. So we have 1 by 2 plus root 3 into 2 minus root 3 divided by 2 minus root 3, which is equal to 2 minus root 3 by 4 minus 3. Using the identity a plus root b into a minus root b is equal to a square minus b. Simplifying it further, we get 2 minus root 3 by 1, which can be simply written as 2 minus root 3. Let's move on to our third example, which is 5 by root 3 minus root 5. Looking at the denominator, we can say that the rationalization factor in this case is root 3 plus root 5, which we have to multiply in the numerator as well as the denominator. So we have 5 into root 3 plus root 5 divided by root 3 minus root 5 into root 3 plus root 5, which equals 5 root 3 plus 5 root 5 divided by 3 minus 5. Using the identity root a minus root b into root a plus root b is equal to a minus b equals, taking 5 as common, we get 5 into root 3 plus root 5 divided by minus 2, which is equal to 5 by minus 2 into root 3 plus root 5, which can be simply written as minus 5 by 2 into root 3 plus root 5. Now, let's take our fourth example, which is 1 by 7 plus 3 root 2. Rationalization factor in this case is 7 minus 3 root 2. So we multiply this in the numerator as well as the denominator, which equals 7 minus 3 root 2 by 7 square minus 3 root 2 whole square. Using the identity a plus b into a minus b is equal to a square minus b square. Simplifying it further, we get 7 minus 3 root 2 divided by 49 minus 9 into 2, which is 18, equals 7 minus 3 root 2 by 31. Our next example is 3 plus root 2 divided by 4 root 2. Here the rationalization factor is root 2. Multiplying this with the numerator as well as the denominator, we get root 2 into 3 plus root 2 divided by 4 root 2 into root 2 equals 3 root 2 plus 2 divided by 4 into 2 is equal to 3 root 2 plus 2 by 8 is equal to 3 root 2 by 8 plus 2 by 8. 2 1s are 2 and 2 4s are 8 is equal to 3 root 2 by 8 plus 1 by 4. Let's move to our next example, which is 5 plus root 6 divided by 5 minus root 6. Rationalization factor here is 5 plus root 6. So we multiply it both into the numerator as well as the denominator. We get 5 plus root 6 whole square divided by 5 minus root 6 into 5 plus root 6, which equals 5 square plus root 6 square plus 2 into 5 into root 6. Using the identity a plus b whole square is equal to a square plus b square plus 2ab divided by 5 square minus root 6 square. Using the identity a minus b into a plus b is equal to a square minus b square, which equals 25 plus 6 plus 10 root 6 divided by 25 minus 6, which equals 31 plus 10 root 6 divided by 19. Our next example is 2 root 3 minus root 5 divided by 2 root 2 plus 3 root 3. Here the rationalization factor is 2 root 2 minus 3 root 3. Multiplying the denominator as well as numerator with this, we get 2 root 3 into 2 root 2 minus 3 root 3 minus root 5 into 2 root 2 minus 3 root 3 divided by 2 root 2 whole square minus 3 root 3 whole square equals 2 root 3 into 2 root 2 minus 2 root 3 into 3 root 3 minus root 5 into 2 root 2 plus root 5 into 3 root 3 divided by 4 into 2 minus 9 into 3 equals 2 into 2 into root 3 into 2 minus 2 into 3 into root 3 into 3 minus 2 into root 5 into 2 plus 3 into root 5 into 3 divided by 8 minus 27 equals 4 root 6 minus 6 into 3 minus 2 root 10 plus 3 root 15 divided by minus 19 equals 4 root 6 minus 18 minus 2 root 10 plus 3 root 15 upon minus 19, which equals minus 18 minus 2 root 10 plus 3 root 15 plus 4 root 6 upon minus 19. Multiplying both the numerator as well as denominator by minus 1, we get 18 plus 2 root 10 minus 3 root 15 minus 4 root 6 by 19. By practicing these examples, you can easily learn how to rationalize the denominator of any given expression. Our next section in this session is all about the laws of exponents for real numbers. So, let's understand and learn some laws of exponents for real numbers. Let a, n and m be natural numbers. First law states that a to the power m into a to the power n is equal to a to the power of m plus n. An example would be 3 to the power 4 into 4 to the power 3 is equal to 3 to the power 4 plus 3. which equals 3 to the power 7. Second law states that a to the power m whole to the power n is equal to a to the power m into n. An example would be 3 to the power 4 whole to the power 3 is equal to 3 to the power 4 into 3, which equals 3 to the power 12. Third law states that a to the power m divided by a to the power n is equal to a to the power m minus n. An example would be 3 to the power 4 divided by 3 to the power 3 is equal to 3 to the power 4 minus 3, which equals 3 to the power 1, which can be simply written as 3. Fourth law states that a to the power m into b to the power m is equal to a into b whole to the power m. An example would be 3 to the power 4 into 2 to the power 4, which equals 3 into 2 whole to the power 4, which equals 6 to the power 4. Do you know what is the value of a to the power 0? You must have already learnt it in your previous classes. It is 1, which means any number raised to the power 0 is always equal to 1. Now, in a to the power m by a to the power n, we take m is equal to 0. Then a to the power 0 by a to the power n gets us 1 by substituting the value of a to the power 0 as 1 by a to the power n, which further simplifies to a to the power 0 minus n using the third law mentioned above, which further gets us a to the power minus n. Considering these two additional results, we can add two more laws in our list. So the fifth law states that a to the power 0 is equal to 1, and sixth law states that 1 by a to the power n is equal to a to the power minus n, which can also be written as 1 by a to the power minus n is equal to a to the power n. An example would be 1 by 3 square is equal to 3 to the power minus 2. Another one could be 1 by 3 to the power minus 2 is equal to 3 square. One more could be 4 to the power minus 3 is equal to 1 by 4 to the power 3. Here we can add one more rule as a by b whole to the power m is equal to a to the power m divided by b to the power m, as this rule will also be required to solve many mathematical problems involving exponents. Now let's look at some of the examples to understand how can we solve the expressions involving exponents by using the rules we have just learned. Our first example is to evaluate 17 square into 17 to the power 5. Applying a to the power m into a to the power n is equal to a to the power m plus n, we get 17 to the power 2 plus 5 is equal to 17 to the power 7. Second example is 17 square into 17 to the power minus 5. Applying the same law as in example 1, we get 17 to the power 2 plus minus 5, which equals 17 to the power 2 minus 5, which equals 17 to the power minus 3 equals 1 by 17 to the power 3. Our third example is 5 square whole to the power minus 7. Applying a to the power m whole to the power n is equal to a to the power m into n, we get 5 to the power 2 into minus 7 equals 5 to the power minus 14, which equals 1 by 5 to the power 14. Next example is 23 to the power 10 divided by 23 to the power 7. Applying a to the power m divided by a to the power n is equal to a to the power m minus n, we get 23 to the power 10 minus 7, which equals 23 to the power 3. Our fifth example is 23 to the power minus 10 divided by 23 to the power 7. Applying the same law as in example 4, we get 23 to the power minus 10 minus 7, which equals 23 to the power minus 17 equals 1 by 23 to the power 17. Our next example is 7 to the power minus 3 into 9 to the power minus 3. Applying a to the power m into b to the power m is equal to a into b whole to the power m, we get 7 into 9 whole to the power minus 3, which equals 63 to the power minus 3, equals 1 by 63 to the power 3. Next example is 3 by 4 whole to the power minus 3. Applying a by b whole to the power m is equal to a to the power m divided by b to the power m, we get 1 by 3 cube upon 1 by 4 cube, which equals 1 by 3 cube divided by 1 by 4 cube, equals 1 by 3 cube into 4 cube by 1, equals 4 cube by 3 cube, which is equal to 4 into 4 into 4 divided by 3 into 3 into 3, which is equal to 64 by 27. Three by 4 to the power minus 3. Applying a to the power minus n is equal to 1 by a to the power n, we get 1 upon 3 by 4 cube is equal to 1 upon 3 cube by 4 cube is equal to 1 upon 3 into 3 into 3 divided by 4 into 4 into 4, which equals 1 upon 27 by 64, which is equal to 1 divided by 27 by 64, equals 1 into 64 by 27, which is equal to 64 by 27. Moving on to the next section. What about exponents as rational numbers in the form p by q? We have already learned that nth root of a is equal to b. If b to the power n is equal to a and b is greater than 0, where a is greater than 0 is a real number. In exponents, we have one more way to write it. So, nth root of a can also be written as a to the power 1 by n. As an example, second root of 3 can also be written as 3 to the power 1 by 2. Another example could be third root of 4, which can also be written as 4 to the power 1 by 3. Do you know how to solve 4 to the power 3 by 2? We know that 3 by 2 can be written as 3 into 1 by 2 or 1 by 2 into 3. Based on this, we can solve this in two different ways. So, in the first format, we get 4 to the power 3 by 2 is equal to 4 to the power 3 into 1 by 2. While in the second format, we get 4 to the power 3 by 2 is equal to 4 to the power 1 by 2 into 3. Let's solve the first one first. 4 to the power 3 into 1 by 2 can be written as 4 to the power 3 whole to the power 1 by 2. Using the identity a to the power m whole to the power n is equal to a to the power m into n. 4 cube gives us 64. So in the next step we get 64 to the power 1 by 2, which is equal to square root of 64, which equals 8. Now let's solve it with the second format. 4 to the power 1 by 2 into 3 can be written as 4 to the power 1 by 2 whole to the power 3, using the same identity as in first format. 4 to the power 1 by 2 is nothing but square root of 4. So in the next step we get square root of 4 whole to the power 3 is equal to 2 to the power 3, which equals 8. We can see that irrespective of the format we use to solve it, the answer remains the same. This is not only for this question, but there are many different ways and methods to solve all the mathematical problems. As long as you are using the right rules and methodologies, it is all good. Generalizing this entire concept, we can define and derive the formulation for the same. Let a be a real number where a is greater than 0. Let m and n be integers such that m and n have no common factors except 1 and n is greater than 0. Then a to the power m by n is equal to nth root of a whole raised to the power m, which can also be written as nth root of a to the power m. Now we can apply these two formulae to solve all the problems involving fractions as exponents. Based on this, we have some extended laws of exponents. Let a be greater than 0 be a real number and p and q be rational numbers. Then the first rule states that a to the power p into a to the power q is equal to a to the power p plus q. Second law states that a to the power p divided by a to the power q is equal to a to the power p minus q. Third law states that a to the power p whole raised to the power q is equal to a to the power p into q. Fourth law states that a to the power p into b to the power p is equal to a into b whole raised to the power p. Fifth law states that a to the power p divided by b to the power p is equal to a by b whole raised to the power p. Now let's have a look at some of the examples to understand these concepts better. Let's do some simplifications using these rules. Our first example is 2 to the power 2 by 3 into 2 to the power 1 by 3, which equals 2 to the power 2 by 3 plus 1 by 3. Applying the first law, a to the power p into a to the power q is equal to a to the power p plus q. We get 2 to the power, LCM is 3, and we get 2 plus 1 equal to 2. To the power 3 by 3 is equal to 2 to the power 1, which is equal to 2. Second example is 3 to the power 1 by 5 whole raised to the power 4 equals 3 to the power 1 by 5 into 4. Applying the third law, a to the power p whole raised to the power q is equal to a to the power p into q. We get 3 to the power 4 by 5. Next example is 7 to the power 1 by 5 divided by 7 to the power 1 by 3. Applying the second law, a to the power p by a to the power q is equal to a to the power p minus q. We get 7 to the power 1 by 5 minus 1 by 3 equals 7 to the power LCM 15, and we get 3 minus 5 equals 7 to the power minus 2 by 15. Example 4 is 13 to the power 1 by 5 into 17 to the power 1 by 5. Applying the fourth law, a to the power p into b to the power p is equal to a into b whole raised to the power p. We get 13 into 17 whole raised to the power 1 by 5 equal to 221 whole to the power 1 by 5, which can also be written as 221 to the power 1 by 5. Now let's have a look at this example, which says simplify root 1 by 4 plus 0.01 to the power minus 1 by 2 minus 27 to the power 2 by 3. It may look a bit complex at first sight, but it is not. It is as simple as any other question we have solved so far. Let's solve it. Root 1 by 4 can be written as 1 by 2 square to the power 1 by 2 plus 0.01 can be written as 1 by 100 whole to the power minus 1 by 2 minus 27 can be written as 3 cube whole to the power 2 by 3, which equals 1 by 2 square. Can also be written as 2 to the power minus 2 whole to the power 1 by 2 plus 100 to the power 1 by 2, as 1 by a to the power minus n can be written as a to the power n. Minus 3 to the power 3 into 2 by 3, where 3 and 3 cancels out. In the next step, we get 2 to the power minus 2 into 1 by 2 plus 10 to the power 2 into 1 by 2 minus 3 to the power 2 by using the laws of exponents. In the first term, 2 cancels out 2. Same way, 2 cancels 2 in the second term also. Thus, we get 2 to the power minus 1 plus 10 minus 9, which equals 1 by 2 plus 1. Solving it further, we get LCM 2 and 1 plus 2 is equal to 3 by 2, and we are done. See how easy it was to solve this question as well. Let's solve one more question. If 25 to the power x minus 1 is equal to 5 to the power 2x minus 1 minus 100, find the value of x. It may look a bit tricky at first sight, but it is as simple as any other question we have solved so far. Here the trick is to simplify the expression in such a way that the left hand side and the right hand side of this equation is represented with the same base. If the bases are same on both the sides, we can easily equate their exponents and solve it further to extract the value of x. So let's do it now. The given equation is 25 to the power x minus 1 is equal to 5 to the power 2x minus 1 minus 100. 25 can also be written as 5 square. So in the next step, we get 5 square whole to the power x minus 1 is equal to 5 to the power 2x minus 1 minus 100. It implies 5 to the power 2x minus 2 by applying a to the power m whole to the power n is equal to a to the power m into n equals 5 to the power 2x minus 1 minus 100. Bringing the term with powers of x from RHS to LHS, we get 5 to the power 2x minus 2 minus 5 to the power 2x minus 1 is equal to minus 100. Now, look at both the terms containing x. Base is same, which is 5. The first term in both the exponents is also same, which is 2x. The sign is also same, which is negative. But the last term varies, 2 and 1. Better to say minus 2 in first term and minus 1 in second term. If we add minus 1 to minus 1, we will get minus 2. Had it been 2x minus 2 in both, we could have taken it as common and solved it easily. So how can we make these two terms similar? First term is 5 to the power 2x minus 2. Second term is minus 5 to the power 2x minus 1. If we multiply this second term with 5 to the power minus 1, being the same base, the exponents will add up, thus giving us 2x minus 2. So, we divide it also by 5 to the power minus 1 to keep the value of the term unchanged, equals minus 100. Since 5 to the power minus 1 divided by 5 to the power minus 1 is equal to 1, and any number a multiplied by 1 gives us the same number a. In the next step, minus 1 and minus 1 add up based on the rules of exponents, and we get 5 to the power 2x minus 2 minus 5 to the power 2x minus 2 into 1 by 5 raised to the power minus 1 is equal to minus 100. Simplifying it further, we get 5 to the power 2x minus 2 minus 5 to the power 2x minus 2 into 5 is equal to minus 100. Since 1 by a to the power minus n is equal to a to the power n, we get 5 in place of 1 by 5 to the power minus 1. Taking 5 to the power of 2x minus 2 as common, we get 5 to the power 2x minus 2 into 1 minus 5, which equals minus 100, which equals 5 to the power 2x minus 2 into minus 4 equals minus 100, equals 5 to the power 2x minus 2 is equal to minus 100 by minus 4. Minus cancels out minus and 4 cancels out 100 by 25. In the next step, we get 5 to the power 2x minus 2 is equal to 25, which could be further written as 5 to the power 2x minus 2 is equal to 5 square. Now, we have the same base but with different powers on RHS as well as LHS of the equation. It means the exponents must be equal to, since the bases on both the sides of equal sign are same. Therefore, 2x minus 2 is equal to 2, which implies 2x is equal to 2 plus 2. Implies 2x is equal to 4, gets us x is equal to 4 by 2. 2 1s are 2, 2 2s are 4, thus x is equal to 2. Solved, and that too so easily. You see, the maths problems may try to scare you at first sight, but if you attack on them step by step, one at a time, and move ahead in a systematic way, you can solve each and every maths problem yourself. Thank you for watching and learning. I hope you are not only watching but practicing too. Keep a notebook and pen while watching and keep solving the questions yourself, along with understanding the concepts. Join the next session to understand and learn the concepts of polynomials, along with many relevant examples to get a better understanding of what you grasp during the session. Subscribe the channel to get notified as soon as the next session goes live, although you are advised not to subscribe this channel if you are not ready to practice solving these questions yourself. You just can't learn maths by watching this or any other video or tutorial. Maths is all about practice, practice and practice. Subscribe the channel, like the video if you are in love with maths, or at least you are ready to fall in love with maths. Appreciate the efforts behind delivering the sessions only and only if you really mean it. I will help you understand all the fundamental mathematical concepts in your course before anything else. It is the key behind working out the solutions to all the maths problems yourselves. Furthermore, I will also help you understand the processes, tips and tricks, steps and procedures to derive the solutions for all the maths problems in your course. If you keep practicing and following, you will learn how to crack and solve all of it yourself. Remember, the more you practice, the more you learn. Please leave your queries, if any, in the comments, and I will try to cover it in the upcoming sessions. Believe me, study more, not anymore.